Lesson 83, Finding Special Products. So we're going to start with perfect square trinomials, but before we do that, I want to use in our notes today for perfect square, we're going to be writing that a lot, so I just want to use a PS for perfect square through this lesson. So we're going to start with perfect square trinomials. So we have a squared plus 2ab plus b squared, and we have a squared minus 2ab plus b squared. So on these, you notice that the a and the b, these are both perfect squares, and this is a perfect square. Anytime you square a number, the answer is a perfect square. So this is a special kind. So if we find the square root of a, the square root of b, multiply them together and times by 2, if we get the middle number, then we can factor it by saying it's a plus b squared. We do the same thing with the second one, but if it equals the negative middle term, then it's a minus b quantity squared. So I'd like to show some examples that are perfect square trinomials. So we have x squared plus 14x plus 49. So we want to look for, to see if this is a perfect square, which it is. Is this a perfect square? Yes, it is. So this is of the first form. So a is going to be the square root of x squared, or x, plus b is going to be the square root of 49, which is 7. So to factor this, it's going to be x plus 7 quantity squared. The second example I want to do is x squared minus 16x minus 64. Now notice that this is a minus sign right here, so this does not follow the pattern. So it is not a perfect square trinomial. And then how about this one? We have 16x squared minus 24x plus 9. I know that 16x squared is a perfect square, and it is 8x, the quantity squared. 9 is a perfect square, that's equal to 3 quantity squared. So if I did 8x times 3, and then times by 2, do I get, oh wait, that's not 8x squared. No, it's 4, because 16, square root of 16 is 4. Okay, so wait, that's 4, this is 4. 2 times 4 is 8, times 3 is 24. So since this is true, we could say that's minus plus. We have the form here, a squared minus 2ab plus b squared. So that is going to equal a, which was 4x, minus 3 quantity squared. So when the middle term's negative, you're going to use the second perfect square trinomial. So the difference of two squares, I think, is easier to recognize, but sometimes kids forget to look for it. So if we had a squared minus b squared, so all we're looking for is two perfect squares that are subtracted. So this is a perfect square, and it's the difference. So difference of two squares. When you factor this, you actually get a plus b, a minus b. And it doesn't matter what order you write it. If you put the subtraction first and the addition second, it means the same thing. So I want to show you an example. We have 100 x squared minus 25. Now both of these are perfect squares, but since we're factoring, we want to take out a 25 first. So we have 4x squared minus 1. Now these are both perfect squares also. So this is 25 times a difference of two squares, which we can factor into the square root of 4x squared, which is 2x, minus the square root of 1 times 2x plus 1. And this is now factored completely. Here's another example. We have 2x to the 6th minus 288. Well, 288 is not a perfect square, neither is 2, but they're both even. So let's take out a 2, and we get x to the 6th minus 144. Now we have the difference of two squares. X to the 6th equals x cubed squared, and 144 is 12 squared. So it's x cubed minus 12, x cubed plus 12, and all of that times 2. One more example, and then we'll be done. So we have negative 36 plus x to the 10th. When this happens, you want to switch the two terms, use the commutative property of addition. We have x to the 10th minus 36. This is the difference of two squares, because x to the 10th is equal to x to the 5th squared, and 36 is 6 squared. So we have x to the 5th minus 6 and x to the 5th plus 6. And that's the end of the lesson.